Hi GOH, this is Unit 4, and in this unit we're going to do constructions. So you've already done a few constructions already, so you're a little familiar with the compass. And this is just talking about that geometric constructions have been around for about as long as geometry has. A geometric construction is simply the creation of a geometric object. It could be a line, it could be a segment, an angle, a triangle, a square. We're actually going to do hexagons also. And they follow three simple rules. The first rule is a straight edge may be used only to draw segments or lines between 2 points. So you're not using a ruler to measure anything in inches or centimeters. A compass can be used to draw a circle or arc. So an arc is just part of a circle. You can always draw a full circle, but lots of times I just draw part of a circle or an arc just to make the picture less confusing. And those arcs have a certain center that they start from, and they have a certain radius. No other tools can be used except for a pen or pencil. The construction, that is the only thing on the Regents that you can use a pencil for, so I would suggest that you do use a pencil. When you're doing these constructions, the compass works much better if your paper is flat on a desk or a table. It's not like in a folder or in a binder or anything like that. All right, so this first one that we're going to do, we're going to construct an equilateral triangle. So I have side AB, which is already drawn for us. That's going to be one side of the triangle. And basically, I want all sides of the triangle to be the same length. So I put one end of my compass on A. I open up the other end to B. See how I'm measuring? I'm using my compass to measure the span between A and B. So I'm going to draw a circle whose center is at A and has a radius the length of AB. So I'm just going to take my compass and draw a circle. Okay, so that's called circle A. Circles are named after the center point. Now I'm going to take my compass and do the same thing, but I'm going to put my compass on point B. So I'm going to put my compass on point B, leave the same setting. Okay, I'm not going to change it because it's already set up with the same radius of AB, and I'm going to draw a circle. There I go. Those two circles are going to intersect in 2 points. All right. It doesn't matter if I use the point above or the point below. Okay, I'm going to use the one above just because there's more space up there. They want me to label that point C, so I'm going to call this C right here. And I am then going to use my ruler, or my straight edge rather, to connect point C to point A and to connect point C to point B. All right. So, and then they want us to just explain why triangle ABC must be equilateral. Basically, you opened up your compass the span of AB, so that was the radius of the circles that you were drawing. So the distance that C is from A and the distance C is from B has the same exact radius as AB, so all of those three sides are equal to each other. Okay, so AC is congruent to BC is congruent to AB. Okay, sorry if this is a little sloppy. I'm doing it in order to do the constructions. I have to do these on my computer, so it's not as easy to write as it is the iPad. All right, so they wanted a little explanation. Both arcs that we drew, or circles, I don't have to draw the complete circle. I just need to draw the arcs where they're intersecting, but I did do the complete circle here. Both arcs have the same radius, that is the length of AB, and the intersection of the two arcs must be a distance of AB away. So AC is equal to AB is equal to BC. Okay, if you need to pause the video, you certainly can. Strangely enough, the purpose of the compass is almost always to establish that the two lengths are equal. Remember, all points on a circle are equidistant from its center. Exercise 2, given the diagram of the circle shown whose center is at R with points S and T on the circle, they want me to explain why RST must be isosceles. Now try and remember what it means to be isosceles, right? How many sides does an isosceles triangle have that are congruent? An isosceles triangle has 2 sides that are congruent. Now which 2 sides are going to be congruent? RS is going to be congruent to RT. Think about that for a second. Why would those two sides be congruent to each other? Think about what kind of line RS is and what kind of line RT is in terms of the circle. All right, RS and RT are both the radius of the circle, and in a circle, all your radiuses are equal to each other. So therefore, that triangle has to be isosceles because RS and RT are congruent. So in a circle, the length of the radius is the same. No matter where I draw that radius in the circle, it has to be the same radius. RS is equal to ST, so the triangle RST is isosceles because two sides are congruent to each other. Okay, next page. Using only our compass and a straight edge, we can create a variety of triangles. So we just did an equilateral ones. One of the golden rules of constructions is always to leave your construction marks. So you have to leave your construction marks when you're doing this. All right, so let me see. And of course, I don't have a compass on this page. And my compass is underneath here. Let me see if I can get it. Click it. Ugh. All right, let me move this whole thing. Sorry about this, guys. But I am, whoops. The compass that I need is like underneath this little video recording that I have. Okay, sorry, I had to pause it because I couldn't get the compass because it was underneath the record button. All right, so we are going to create an isosceles triangle. Now remember, isosceles, we just talked about that on the other page. An isosceles triangle has two sides congruent. So I want to create an isosceles triangle. MN is going to be the base, so that is not going to be one of the two congruent sides. But the legs are going to be congruent, and they are going to be the length of AB. So I put one end of my compass on A. I put the other end of my compass on B. See how I'm measuring the span of AB. So that is, that's going to be the radius of the circles or the arcs that I draw. I'm going to draw two arcs, all right, that are going to have this exact radius of AB. So put one end of your compass on A, one end on B. I now come over here to point M. Leaving the radius that I just drew, I can draw a complete circle or I can just draw an arc. I know that my third point of this triangle is going to be up above, so I just need the arcs up above. Then I'm going to come over here to point N with the same exact radius that was AB, and I'm going to draw an arc. Where those two arcs meet, that is the third point of my triangle, okay? And I'm going to connect that point to M, and I'm going to connect that point to N. Now, this is an isosceles triangle because the two sides are the same length. And what is that length? That length is AB. So basically, these two sides are equal to each other. How do I know that? Because I measured AB. They're actually the same length as AB is. Okay? In the exercise 4, I'm given triangle ABC. I'm going to construct RST such that the triangles are congruent. Now, the easiest way to do this is to make them congruent by side, side, side. We just talked about congruent triangles in Unit 3, and you know there are other ways to prove triangles congruent, but the easiest way to do a construction is side, side, side. You haven't learned how to construct an angle. You are going to learn how to do that, but it's a harder construction. So basically, I'm going to take each side and I'm going to copy it over here on that other triangle. So I'm measuring AB. I put one end of my compass on A, one end on B. I come over here to R. I put the compass on R and I make a little arc. That's going to be S. Now I come over to here and I'm going to measure AC. And I'm actually, because I'm going to be off the paper, I'm going to have to do it this way. All right, otherwise I would be off my paper. So I put one end of my compass on A and one end of my compass on C. Make it as exact as you can. All right, so I'm measuring AC. Now I'm going to come over here to R and I'm going to mark off the arc. I know that C is above it and a little bit to the left, so that's where I need my arc to be. Above and a little bit to the left, and that should cover it. If you want to do a whole circle, you can. I find it a little overwhelming when there's a whole circle like that. All right, so now I'm going to measure from B to C. Okay, I'm putting one end of my compass on B and one end of my compass on C. And now I'm going to come over here to where my S is, and I'm marking off. Now where those two arcs meet up above, that is point T. Okay, so I use my straight edge now, and I connect that point of intersection to R, and I connect that point of intersection to S. And I'm going to label this S right now, and I'm going to label this one up here T. I know the order of the letters because remember the order of the letters matches up. So A is congruent to R, B is congruent to S, and C is congruent to T. Now we're actually going to do a little proof why those two triangles are congruent. Why is RS equal to AB? Well, because I just did a construction and I made sure that they were congruent to each other. So they are congruent by construction. So that's going to be a new reason that we have. Why is RT congruent to AC? Again, by construction, because I measured that side, and all sides are congruent to each other. And well, those sides are congruent. I'm getting ahead of myself. Why is ST congruent to BC? Same thing, by construction. All right, and then why are my triangles congruent? Well, basically, AB was congruent to RS by construction, and then RT is congruent to AC by construction. And then ST is congruent to BC by construction. So the reason why the triangles are congruent, that last step, is just going to be side, side, side. Okay, so we're going to practice some more constructions in class tomorrow, some more triangle ones.